Okay, now it's recorded. Perfect. All right. So I think last week we discussed how to find the domain of function, right? We used the equations and also graphs to find the domain. But I think for the graphs, we only had like just one example, if I'm not mistaken, right? So I'm probably gonna do more examples today, and then I'm gonna discuss. So after the domain, we're gonna discuss the range of a function, right? So let me just remind you quickly the definition of a domain. So we said the domain of a function f of x, function f of x is the set of all x values that you can input. Okay. So in other words, so what I'm saying here is that if x it's not in the domain of the function f, then f of x it's actually undefined. And if x is in the domain, then f of x would be some just some number. Okay, so what do I really mean by this definition is the following. So the idea is that if you say, well, if like some number is not, let's say, for example, 5. So we have, let's say, a function f, right? We have a function f, some function f of x. Okay, some function f of x. And then if you say like 5 is not in the domain, 5 is not in the domain. So what do we mean here is that, so that means that f of 5 is actually undefined. So this is, if 5 is not in the domain, then f of 5 would be undefined. And what do I mean by undefined? It means that there is no corresponding output y. Okay, so there's no, so in other words, no corresponding output y. Okay, so if my input x is 5 and this 5 is not in the domain, it means that there's no corresponding output y, right? Now, if 5 was in the domain, okay, then, well, then the corresponding output y would be well defined, right? So then f of 5 would be just some number, okay? It could be some, I don't know, just some number here. It's gonna be some number, okay? And so in other words, the corresponding output y is well defined. Corresponding output y is well defined. There's going to be some number. Okay, so that's what we mean by the domain of function f. All right, so yeah, as I said, so last week we discussed how do we find the domain of a function. First, using equations, right? We discussed how we can find the domain using equations. So let me just write down here for you. So first, using equations. Okay, so again, so here I'm saying, so well, so the question is, how do we find? Right, so the question is, so how do we find the domain of some function f? So how do we find domain of any function f of x? And the answer, so first, so if the function f is expressed or described by an equation, right? So first, using equations. Okay, so we discussed this last week, right? Okay, Now, using graphs. So if your function f, again, guys, there are infinite ways actually to describe a function f. The two most important ways to describe function is either equations or graphs. Now, so now if you want to find the domain of function using graphs, so what I said last week, I said we need to use vertical lines. So the idea here, so to find the domain, we use, yeah, oh yeah, yes, Louis, I got you, yeah, yes, thank you. Yes, so to find the domain, we use vertical lines. Okay, vertical lines. So if a vertical line intersect the graph, if you have some intersection with the graph, then the corresponding input x would be in the domain. Right. So let me give you an example, and then we're going to have an exercise. All right. So again, because I think last week we just had probably just one example. So I think it's a good idea to do more examples. So here's one example. We use the vertical lines, of course, not just one vertical line. So of course, here's an S. Yes, so example. So for the domain, again, guys, we don't really care about the output y, right? We don't really care about the vertical axis. What's really important for us, when you find the domain, it's the x-axis, is the horizontal axis, right? This is, so the horizontal axis, that's my x-axis, that's the axis of inputs, right? So we are just interested in the x-axis. We don't really care about the y-axis when you find the domain. So this is the y-axis here, right? Now, so let me just graph some function f. Yeah, I'm gonna just put some numbers here on this number line. So this is, let's say, 4, 1. This is of course 0, 1, 2. So I mean, an axis is just like a number line. Now, let's say we have the following function. So let's see here how it works. So right, of course, here on the left we have we're gonna have negative infinity, and here on the right it's positive infinity. Let's say this is -5 right here, etc. So yeah, so here's the graph of my function f. And here, all right, so this is my f of x. So now I want to find the domain, right? So so the question, of course, is to find the domain. Okay, so as I said, the idea would be to use vertical lines, right? So you always start from the left, okay? You always go from left to right. So you start from the left. On the left here, of course, like you start with negative infinity. When you draw this vertical line, as you can see, there is no intersection with the graph. So intersection with the graph, I mean the red, the red curve. Okay, so my blue line doesn't intersect the red curve. Okay, so there is no intersection with the graph. And so, of course, you continue here with your vertical lines. And so the first time you're going to have the first intersection, as you can see, at -4, right? So if you draw the vertical line passing through -4, you're going to have this intersection, right? This one here, right here. You see this this green circle? As you can see there is an intersection with the intersection of my blue line with the red graph, right? And so that means that the corresponding input x So the corresponding input x is a -4, of course, right? So again, I don't really care about the y-axis, the vertical axis. My input x is on the x-axis, which is the horizontal axis. So this -4, because there is an intersection, it means that the corresponding output y is well defined. And so this -4 will be in the domain, okay? Domain of f. Now, of course, I'm going to continue with my vertical lines. And here, of course, we do have an intersection here, okay? Even if it's not like a full circle, but still you do have an intersection. So you're going to have intersection starting from -4, and as you can see, all the way to right here. Of course, you do have an intersection right here, etc., all the way to 0. Okay, now 0 is like a small problem here at 0. The thing is, just remind you, when you have this empty circle, not the full one, this one here, this means that the point is not, it's excluded from the graph, right? It's excluded from the graph, so it doesn't belong to the graph. So if it doesn't belong to the graph, it means that there's no intersection there. If you take this blue line passing through 0, here's my blue line passing through 0, it doesn't intersect the graph at 0, because at 0, as you can see, there's this empty circle which is not which doesn't belong to the graph, so there's no intersection there. So like the first interval here in my domain would be like from -4 to 0, -4, comma 0. So the comma means -4, comma 0. So here, that's an interval. -4, it's included because there is intersection with the graph. So I'm going to use a bracket. If you have if you want to include the number, so this is included because I do have intersection at -4. The thing is, for 0, 0 is going to be excluded, right? So we're going to use parentheses for 0. Okay. Now let's continue with the domain, right? So after 0, as you can see, between 0 and 1, if you take a vertical line between 0 and 1, there will be no intersection with the graph, right? So the interval between 0 and 1, it's not it's not included in the domain, right? It doesn't belong to the domain. Now I'm gonna have again intersection at +1. So as you can see here, at +1, when you draw this vertical line passing through +1, as you can see, there's an intersection right here at this point. So which means that this +1, the corresponding input x, again, I don't really care about the height or the level y. All I care about is the x, the input x. So my input x, which is +1, it's in the domain. All right. And so, well, you're going to have intersection from 1, and then you arrive at 2. As you can see, at 2, there's well, there's an empty circle and a full circle. Now, so if you take this vertical line at +2, well, there's an empty circle, which means that it's not it's excluded, right? But then we do have an intersection here. There's a full circle right here, as you can see. Okay, so which means there's an intersection. So if there's an intersection,
Did anybody else's screen freeze?
Yeah, I'm
I
frozen.
think,
I can't hear him.
yes. Professor, I think you are muted.
Okay, guys, I think I think my Zoom froze on my iPad. No, you don't have to do anything. I think I'm just I have to. Do you hear me now?
Yeah, I hear you.
Right? Yes. Okay. I think the Zoom froze on my iPad, so I'm gonna just relaunch the thing here. I'm sorry about that, guys. Okay, let me just share again the board. Okay, I think you probably hear me now. Okay, I'm gonna share again. I'm gonna share again my screen. Okay. 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 I guess now you hear me, right? Okay, I'm gonna. Okay, here. No, I think probably no, the problem is fixed. Okay, sorry about that, guys. Yeah, I was saying if you do have any question about this example.
Okay, but hold on, Professor, for me at
Yes.
least, you cut off like right after you wrote the -40.
Oh, just
Like
right
you
after.
froze, like
Oh, okay.
after
yeah,
that.
Okay. Okay. Yeah. So yeah, we had this first interval from -4 to 0, and then I said we're gonna have again intersection at, if you use your vertical lines, you're gonna have intersection again at +1, right? This +1 here, because we do have this full circle at a +1, right? Right here. And so if you continue with your vertical lines, you're gonna still have intersection. And the only problem here is at 2, as you can see, there's this empty circle right here, right? And there's also a full circle right here, okay? So of course, the empty circle means that the point is excluded from the graph, okay? But the full circle means that it's included, right? The full circle means that the point is included in the graph. So when you draw a vertical line passing through the +2, right here, +2, okay, then you don't really care about the empty circle, because we do have a full circle, which means that the +2, it's included in the domain, right? This you have a full circle right here, so your +2, it's included in the domain, so you don't have to stop at +2. You can continue with your domain, and you're gonna again still have intersection, right, all the way to positive infinity. Okay, positive infinity, as you can see here, we have like an arrow in the bottom right here, and the arrow means that the graph is gonna go all the way down. Okay, it doesn't stop there. So that's why the second interval in my domain would be +1 all the way to positive infinity. And as I said, I was saying the +2, we don't have to stop at +2, even if you have this empty circle at +2. But the thing is, we do have a full circle right here. So you don't have to stop at +2. You can continue all the way to positive infinity. Okay, so we
I have a question.
Yes, please.
I just want to clarify, when it's positive infinity or negative infinity, you always end it with a parentheses?
Oh yeah, it's always, because positive or negative infinity, they are not real numbers. So that's why we use always parentheses. Yes, with the
Okay.
infinity.
Thank you.
Any other question, guys? So here we have like two different intervals, right? Two separate intervals. So the first one from -4 to 0, and the second one from 1 to positive infinity. And the important thing here, guys, is that you don't have to stop at +2, even though you have this empty circle, because you have the full circle. So it's included, so you don't stop at +2. You can continue with your domain all the way to positive infinity. All right. Okay, so let's do an exercise. Okay. So here's an exercise. All right. Yeah. Am I recording? I hope my recording didn't stop.
No, it seems to
No,
still be
it
recorded.
still go. Okay, 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 perfect. All right, so here's an exercise. Okay, let's do okay, let's do two graphs. First graph right here. X-axis. So positive infinity, of course. Here's negative infinity. This is negative -1, -2, 1, 2, -4. And here's my graph. Okay, so all right, and then so that's my f of x, my first graph, second graph. Number 2. All right, so positive infinity. One, two, and then here's my graph. As you can see, you guys, again, I don't really care about the vertical axis, right? Because this is the domain, it's just about the input x, the horizontal axis. So yeah, so let's see here. All right, let's do this like this right here. All right, there's my f of x. Okay, guys, so please try to find the domain, right? And so the question, of course, is to find the domain. Find the domain. So you're saying for number one, -1, 0, very good. And then 1, 3, absolutely. Yes, very good. Just don't forget the symbol for union, right? The capital U between the intervals, right? Okay, what about number two? Any guess for number two, guys? Okay, does anyone need more time to think about the problem? All right, probably you're done. Okay, so for number one, we want to find the domain, right? So let's go with our vertical lines. So let me just write it down here. So the answer for number one. So as usual, I'm going to go with my vertical lines. As you can see here, there's no intersection with the graph, etc. So first time I'm going to have intersection would be at -1 right here. As you can see right here, there's an intersection. So I'm going to start my domain at -1, right, comma, and then we're going to go to, as you can see here, between -1 and, of course, this is 0, right? This is supposed to be 0 right here. So yeah, so my domain would be like from -1 to, and then you have to stop at 0, because as you can see here at 0, this is this empty circle, which is excluded from the graph, doesn't belong to the graph, right? So we have to stop at 0, okay? So we're gonna have -1 to 0, comma 0. -1 is included because we have this full circle, and then 0 is excluded, right? So we have to stop at 0 again, guys, because it's excluded, right? We don't have a full circle at 0, right? So we have to stop at 0. Now, after 0, just be careful between 0 and 1, right? There is no intersection. So and then you're going to have intersection again at +1 right here. Okay, so I'm going to have, so I got my first interval, union, capital U. So my second interval is going to start at +1. +1 is included, comma, and let's see how it goes. So after +1, you're going to have intersection. Now you arrive at +2. Do we stop at +2? No, we don't stop at +2, right? Because we do have a full circle at +2, right? So we don't really care about this empty circle right here. Okay, this one here, we don't really care about, okay? What's really important for us is the full circle. So because of the full circle, I don't have to stop at +2. I can continue until, of course, when you arrive at +3. When you arrive at +3, you have to stop there, right? Because we have this empty circle. So, so my second interval will be like from, you see, +1 and then to 3. And then I have to stop at 3 because it's excluded from the graph. Now, so let me just write down here a +3. +3, as I said, it's excluded. So that's parentheses, union. And now my third interval is going to start at, let's see, my third interval. So between 3 and 4, as you can see, there's no intersection. And I'm going to have, so my third interval is going to actually start at +4, right? Because you do have intersection here. So you start at +4 and to positive infinity, right? Because as you can see here, we still have intersection all the way to positive infinity. So it's gonna, my third interval is gonna be like from 4 to positive infinity. 4 is included because it's a full circle there, and infinity, of course, is always excluded. Right? Any question about the first graph, guys? How I got this domain, the 3 different intervals? Okay, no, perfect. Now for number 2, I think Louis, you have an answer for number 2. So you're saying from -5, 3, that's correct. Then -2, -1, that's good. 0 to positive infinity. Yes, perfect. That's exactly the answer. 0 has to be excluded. Absolutely, that's the answer. So very good, Louis. So that's so for number 2, the answer would be 2. So the answer. So I'm gonna just explain again very quickly how we get the answer. You always start from the left. Okay, in math, you go from left to right. So negative infinity, there's no intersection, etc. First intersection would be at -5 right here. So you're gonna start having intersection -5 all the way to, and then you have to stop at -3, right? Because it's not included. So that will be my first interval, -5 to -3. Now, between -3 and -2, there's no intersection. Now, between -2 and -1, there will be an intersection. Here it's -1. Sorry, I forgot the minus sign. Here should be minus. So yeah, I was saying between -2 and -1, you're going to have an intersection, right? Of course, -2, it's not included, and -1, it's a full circle, so it's included. Okay. And then between -1 and 0, as you can see here, there's no intersection. And then my third interval will be like from 0 to, from 0 to positive infinity. Okay, because of course you're gonna have intersection there. So the answer would be like, as Louis said, -5, -3. -5 is included because we have a full circle there. -3, it's excluded. Union, my second interval would be from -2 to -1. -2 is excluded, so parentheses. -1 is a full circle, so it's included. And then union, my third interval, which is from 0 to positive infinity. Infinity is always excluded, and 0 in this case is excluded. All right. Any question, guys? So that's how you find the domain. So probably you're gonna have an exercise in the homework about finding the domain using graphs or equations. All right, so if there's no question about the domain, so now let's move to the range. Okay, so as you can see, guys, in the domain, all we care about is the values of the input x, right? We don't really care about the vertical axis. Now in the range, that would be a different story. So now in the range, so next. So in the range, you're going to be interested in the values of the output y. Okay, so so number 2 here, the range. Okay, so let me first define what's the range. The range is of a function f is the set of all y values Okay, it's not the x values, but the y values the function attains. Okay, so the range of function f of x is the set of all y values the function attains. Okay. So what do I mean by this definition of a range? Well, so if you have some output y, so we have some value of y. So if y, so the idea here, so if, let's say you take a number, let's say if 5 is not in the range. Remember, if, for example, for the domain, if 5 is, it's not in the domain, okay, it means that the f of 5, it's undefined. There is no corresponding output y. Now, for the range, if 5 is not in the range, it means that there is no corresponding input x. Okay, then there is no corresponding input x. Okay, in other words, there is no x, I mean, there is no number says that f of x is equal to 5. Okay, so there is no such x. There's no x for which f of x is equal to 5. Okay, that's what I mean by 5. It's not, if 5 is not in the range. Okay, 5, it's not in the range. Now, if 5 was in the range, again, this 5 is just a random number. I'm just taking a random number, and I'm saying if my random number isn't, it's not in the range, it means that there is no corresponding input x. Any question, guys? Okay, probably not. No. So what I'm now, if this number, random number 5 is in the domain, sorry, in the range, then there is some number, then there's some x, then there is some number x, there is a corresponding input x. Okay, which means there is some number x, let's say 3 or 2. There is some, there is some number. For example, let's say 2 says that f of 2 would be equal to 5. Okay. Again, this 5 and 2 they're just some random numbers, right? But what I'm trying to explain here is that if we have some number in the range, it means that there is a corresponding input x. So there will be a number, let's say 2 says that f of 2 is equal to 5. And if it's not in the range, then there is no such number. Okay, so that's the idea of the range. Guys, again, if you have questions, I mean, just let me know. Right now, we're gonna try to find the range, right? So I'm gonna first use graphs to find the range. Okay, so now the question, of course, as usual, how do we find the range? How do we find the range? Okay, so first, well, let's use graphs. Using graphs. Okay. Well, probably you can guess, you can, for the domain, we use the vertical lines to find the domain. Now for the range, you can probably guess that I'm gonna use horizontal lines. Okay, so for the range, so we're gonna use, the idea here would be to use horizontal lines. Okay, so so what do I mean by using horizontal lines? I mean, if a horizontal line intersect the graph, then the corresponding output y would be in the range. Then the corresponding output y is in the range. Y. And as you can see here, I don't really care about the output input x, the horizontal axis. So that my output y would be on the vertical axis, right? This is on the vertical axis. This is on corresponding output y is in the range. Okay. Okay, so let me show you now with an example how it works. An example. And in this example, I'm gonna try to find the range. Okay, so here's my 2-axis. This is my x-axis, and this is my y-axis. So now in the range, I'm gonna be interested in the y-axis. So I'm gonna need the negative infinity and positive infinity on my y-axis. So, guys, for the x-axis, you go like from left to right, okay? Now for the y-axis, you go like from the bottom to the top, okay? So now I'm gonna put some values on the y-axis. So let's say this is -3, -2, this is -1, here's +1, this is of course 0, etc. Anyway, so let's say here's my graph of f of x. Okay. And then okay, so that's my f of x. That's a graph of my f of x. This is a full circle right here. All right. So, okay, so as I said, for the range, we're gonna use horizontal lines, and you go from the bottom to the top. That's really important, okay? So you use horizontal lines, go from the bottom to the top. Okay. All right, so what will be the answer then? Let's see. So what will be the range? Well, so here's my vertical line, horizontal line, sorry. And as I said, you start from the bottom. And the bottom, of course, you have a negative infinity right here, right? And as you can see in the bottom of negative infinity, you do have intersection, right? Right here, we do have intersection. There's an intersection here. There's an intersection here. So you can go, so we do have intersection. And again here, I don't really care about the x-axis. I'm gonna go with the y-axis, the vertical axis. And as you can see here, like when you arrive at -3, you do have intersection. Actually, you have 2 intersections, not just one, right? You have intersection here and also right here, okay? So I'm gonna continue, still have intersection, so I can go all the way. Here I have -1. Well, even well, here you have the empty circle, but you don't really care about this empty circle because you do have intersection right here and right here. Okay, and if you have like just one intersection, then it's gonna be included in the range. Okay, so then your range gonna continue all the way to the top right here. Here at +1, you do have intersection. Actually, you have two intersections, right here and right here. So you can continue, and then you arrive at +3. As you can see here at +3, you have like a empty circle, this one right here, which means that my horizontal line at +3, it doesn't intersect the graph. So +3 is not supposed to be included in the range. And then after that, after +3, as you can see, if you go up here, there will be no intersection, right? So my range would be like, you start from the bottom, from -infinity, and your range would be like from -infinity to +3. Okay, and you have to stop at +3, of course, because there will be no intersection at +3. So the answer here for the range, so the range here would be like from -infinity, comma, +3. And both, of course, are excluded. Louis, you're saying, I don't understand your remark, Louis. You're saying for range and example. Yeah, so for my example, the answer would be, as I explained, -infinity, +3. And again, guys, for the intervals, you always go like from the small number to the large number. So if you have like an interval, let's say between -1 and +1, so then the interval should be like -1, +1. That's because you start from the smallest number. Do not include all the values from each function. Well, we only have one function here. So you're probably talking about the domain, Louis, right? I think you're talking about the domain, not the range. So the domain would be a different sort. Excuse me? Yes, please.
I'm just clarify.
Yeah.
There's like three lines. Like,
Yeah, and the
do
graph.
you only include those three lines on the graph?
Yeah.
You only include that large number that goes into infinity in this case, the one that's in from 3 to -infinity.
Yes, I mean, even if I have like 3 different lines in my graph, I don't really care about which one we're gonna have intersection with. So for example, for example, at -3, as you said, like here at -3, right here. Okay, so if you take this horizontal line, okay, at -3, I do have two intersections actually, right here and right here. Okay, I don't really care where we do have intersection, if it's like in the third line or the second line of the graph. Okay, if you have just one intersection, you can have more than one intersection, but if you have just one intersection, then you know that your number is going to be in the range. You see what I'm saying? So like my -3
Okay.
here.
So in this case, those two other lines aren't relevant because they intersect with the larger line.
Yeah. Mm-hmm.
Got it.
Mm-hmm. Yeah, that's the. Mm-hmm. So and yeah, and for example, like if you are somewhere between -1 and 0. So for example, right here, this level here. Okay, you see this level? Somewhere between -1 and 0. You can see here we do have like 3 different intersections, right? But it doesn't really matter if you have 3 or 2 or 1. If you just have 1, then that's enough to say, well, your number is going to be in the range. Yes.
A quick question,
Please.
just to clarify.
Yeah.
If if you had those two lines, but they didn't intersect, would you then include them in the range?
Yeah, you're saying like if you don't have intersection here and here, and you have just one intersection right here, like this one
Like,
here.
for example, let's assume that the line that you have furthest to the left is
Mhm.
above 3. It's at like 5, and then it goes down
Okay.
to 4. So it
Okay.
intersects with that other line. Do you include it then?
No, you don't. You don't. Of course, you don't. I mean, they're not. No, you don't include them, of course. Yeah, so probably let me just probably explain. I mean, I'm gonna just show you what I understood from your question. Okay, so you're saying like, for example, if you had like this line right here somewhere, right, and then just like this 2 here in the bottom, like this, and you're
Yeah.
saying, and then you're saying like, well, I don't know, like somewhere right here, then your question is if this number right here would be in the range or not.
No,
Is that no?
that the line furthest to the left, the one that's up there,
Mhm.
in the first quadrant, would you include that line?
No, that
Along-
line, yes, yeah. I mean, that line is supposed to be, yeah, it's supposed to be included in the graph. It's in your graph.
So
But-
you would
but-
include that line in the first quadrant, and do you also include the other line, the one that's going down to infinity? So
Oh
would you
yeah,
have two?
yeah. I mean, all the lines that are supposed to be part of your graph, they are all included in your graph. But now the question is probably, so if you take a horizontal line, okay, the question is, does your horizontal line intersect one of these lines, right? That's the question. If it just intersect just one line, then that's enough to say, well, then your corresponding, this number here would be in the range. That's what I'm saying.
I'm just trying to clarify. Like,
Mhm.
you see that first line that you have, that line
The
that's
one, this one here?
in the one, no,
Oh, you mean the graph?
that red line, the red line that you have up
right here.
there.
Okay. Mhm.
Yeah, that first line that you have there, would you
Mhm.
include that in the range along with the larger line that you have
Oh,
in the
yes.
fourth quadrant?
Oh, yes, yes.
So you would include both those values.
Yeah, yes, yes.
Okay.
Yeah, so,
Okay.
mhm,
Just want to
yeah.
clarify that.
Yeah. And we're gonna have more examples, so don't worry about it. Yeah.
Okay, I'm sorry,
okay,
to
let's-
piggyback off of that then, so would it still be like one bracket or one parenthesis? Or would like it be broken up like the domain is?
Well, I mean, right here, it's not, well,
Or are we
probably
getting
should-
ahead
I'm
of
gonna-
ourselves?
No, I'm gonna, let me do a different example, like with numbers, because here it's like, it's a mess, right? Let me just do like a very similar example, and we'll see how it works, okay? Because here, like this graph right here, it's just, there are no numbers, so I can, I can't really answer correctly probably your answer, okay, your question, all right? So let me do more examples, and we'll see. Okay, let me just erase this mess here. Probably bigger eraser. Okay. Okay, let me do one more example. And I'm gonna try to answer questions with this example. So this is example number 2. Your question probably is like something like this, where you have like, let me see. Okay, right here. So here in the bottom, of course, will be negative, positive. Let's say here somewhere -4, 2, -1, here 1, 2, 3, 4, and here's 5. Okay, so let's see here. Okay, so this is just empty circle right here. And then I'm gonna have something like this here. All right, and then something like this right here. Okay. Okay, so I hope I'm gonna be able to answer your question with this example. So I have like 3 different components of the graph, right? Right, so and of course I'm gonna try to find the range. So what I'm gonna do, I'm gonna start from the bottom, as I said, right here. So you do have intersection here in the bottom. So your range is supposed to start at like -infinity, and you're gonna go all the way to, and then you need to stop at -2. You see here at -2, you do have intersection at this point. So you need to stop at -2 because, as you can see, between -2 and -1, there is no intersection. So like my first interval in the range in this case would be like from -infinity to -2, right? So let me just write it here. So the range would be like, so start -infinity, comma, -2. -2 is included, of course, but then, as I said, we have to stop at -2 because I'm going to use different color. Let's say green. So as you can see here, between -1 and -2, there will be no intersection, right? Now we're going to have we're going to have like second interval, which starts at -1. So as you can see, sorry, different blue. So at -1, we do have an intersection here, right here, right? And so we're gonna have, so the second interval from -1 to +1. So we have to stop at +1 because as you can see, after +1, like between +1 and actually +3, somewhere right here, there's no intersection, right? So so my second interval will be like from -1 to +1, and both are included. All right, now, as I said, between +1 and +3, there is no intersection, right? But then you're gonna have again intersection, or so your third interval is gonna start at a +3, right here at +3. Well, you don't have intersection +3, but just right after +3, you're gonna have intersection, right? So right here, for example, all the way to, so from +3 all the way to here at +5, right? Right here, you do have an intersection here at +5. So you're gonna have like a third interval, like from +3 to +5. So there will be a third interval from +3 to +5. +3 is not included, and +5 it's actually included, right? Now, after +5, of course, there will be no intersection, like for like somewhere right here in the top, there will be no intersection, right? So then the answer is we're gonna have these 3 different intervals. But as you can see, guys, so my graph is given like by 3 different components or different lines. But you don't really care about the components of your graph. So you go with your horizontal lines. If you do just one, you do have just one intersection, then you have to include the y in the range. Okay. Does this example answer your questions, guys? I mean, so that's the idea. Even if you have like different components in the graph, all you care about is just your intersection with the horizontal lines, right?
Yep, got it.
Okay, perfect. Is there any other question about this example? Okay, perfect. So here's an exercise then. Okay, let's go with an exercise. Exercise number 1. put negative v here. This is of course 0, 1, 2, 3, 4. Here's my positive infinity, and here's my graph. So let's see how it works. All right, here. Okay, right there, and then somewhere right here. Right, and then okay, so that's my f of x. Okay, and then you want to find, of course, the range. Number 2, that's my first graph. Number 2. Negative infinity. Here's negative v, negative 2, negative 1. This is 0, of course, 1, 2. And then here's my graph. Of course, here in the top, you have positive. This is supposed to be positive infinity, right? This is negative infinity. All right, guys, so please try to find the range. Okay, so the question, of course, is to find the range. Louis, you are saying negative 3, negative 1, 0, 2, 3, 4. Yes, very good. Excellent. Yes, absolutely, Louis. That's the answer. Number 2, let me see. So negative.
Can I ask you a question about number 2?
Yes, please.
So since the infinities aren't included, and since you didn't include the 0, are we even paying attention to that?
Oh, yeah.
Could it just be 2, comma, positive infinity?
So that's one interval. So here the range is going to be given by like 2 different intervals, right? We're going to have like 2 separate intervals. So the second interval, yes, that will be the 2, as you said, the 2 positive infinity. That will be like your second interval. But there is also a first interval, which is like from the bottom, from negative infinity to 0.
Ah, I see. Thank you.
Mm-hmm. Yes, Louis, that's correct answer. Very good. Does anyone need more time, guys, to think about this problem? All right, so probably you're done. So Yes, so let's start with the first graph, right? So so what will be the answer for number 1? So let's just put my answer right here. Okay, so let's start from the bottom as usual. Here's in the bottom at negative infinity, and as you can see, there'll be no intersection right in the bottom. Now, the first intersection is going to be at -3. As you can see right here, you do have an intersection. So you start your range at -3, and then you can go to actually to -1. But then you do have an intersection, of course, at -1, but then you have to stop at -1, right? Because as you can see, between -1 and 0, like if you take a horizontal line between -1 and 0, there will be no intersection. So yeah, so your first interval would be like negative infinity, which is of course excluded, -1 included, union. Now, as I said, there will be no intersection between -1 and 0, but then between 0 and 2, if you take a horizontal line between 0 and 2, as you can see, you do have an intersection. Well, just one intersection, but that's enough, right? So if you do just one intersection, then that will be in the corresponding y will be in the range. So yeah, so you're gonna have a second interval like from 0 to 2, right? But then you have to stop at 2 because, as you can see, between 2 and 3,
Excuse me,
right
Professor.
here. Yes, please.
You put negative infinity for the answer?
You mean the answer?
Yeah.
Yeah, it's negative infinity to -1, and then capital U.
It's not -3?
Oh, sorry. You're right. Sorry, you're right. I'm sorry.
Yeah.
It's negative. Very good. Thank you.
They,
That's my bad. Yeah, I meant -3, of course. And -3 actually is included. Very good. Thank you. And then, yes, so then from 0 to 2, 0, it's included. 2 is excluded. Positive 2 is excluded, right? Union. And then, as I said, you have to stop at +2 because between +2 and +3, there'll be no intersection, right? Like this green, as you can see, this horizontal green line here, right here, there'll be no intersection. And then between 3 and 4, if you take a horizontal line between 3 and 4, you're gonna have an intersection right here. So this interval here between 3 and 4 would be my third interval in the range. So union 3, 4. Oops. I'll just erase this right here. Yeah, so 3, 4. 3, it's excluded, right? Because of this empty circle, a circle right here, right? So 3 is excluded. 4 is actually included. Okay, so that'll be my third interval. That's the answer for first graph. Any question, guys? Okay, perfect. So now for number 2, the answer for number 2 would be like, so the answer, so the range would be like, so you start from the bottom, and in the bottom, of course, there's a negative infinity, and you do have intersection because of the arrow. So there will be intersection right here, for example. So you can start from negative infinity all the way to 0. But then you have to stop at 0 because between 0 and 2, as you can see here, between 0 and 2, there will be no intersection, right? So you have to stop at 0. So my first interval would be from negative infinity to 0. Both are excluded. 0 is excluded because there's this empty circle. And then my second interval, so union, my second interval would be like from 2 to positive infinity, right? So as you can see, if you take a horizontal line between 2 and positive infinity, somewhere right here in this interval, you will have an intersection. So that will be 2 to positive infinity. Positive 2, of course, is included because of this full circle, and infinity as usual excluded. Any question, guys? Okay, perfect. Yeah, I think we spent a lot of time about studying this domain and range, but I think we went over almost everything here. I mean, how to find the domain and the range, etc. So I think it's time for us to move to the next notion, right? Which is the notion of the x and y intercepts. All right. So
Wait, Mister,
yes,
are you gonna teach us how to find the range through an equation?
yes, I'm gonna do that after at the end of this section. Yes, after the
Okay.
because yeah, of course. So yeah, let me I'm gonna talk first about this x-intercept, y-intercept, and then we're gonna see how to find the range using equations. So next, I'm gonna study x-intercept and y-intercept. Okay, so let's start with the x-intercept, guys. The x-intercept, it's I think it's not really hard notion. What do we mean by x-intercept? So x-intercept are just the intersection of the graph with the x-axis. So this is when the function or the graph of the function crosses the x-axis. So x-intercept is so by definition, it's just the intersection of the graph. That's why it's called the x-intercept, intersection of the graph with the x-axis of the graph with the x-axis. All right. So, or in other words, this is when the function or the graph crosses when the graph crosses the x-axis. Okay, so so the question is how, first I'm gonna try to find the x-intercept. I'm gonna show you using graphs and equations how to find the x-intercept. So how do we find x-intercept? So I'm gonna start with the graph because I think that the graph are easier. So how do you find the x-intercepts? So first, using graphs. Okay. So let me go with an example. So here's my x-axis. This is my y-axis. So let's say this is 0, 1, 2, 3, so -1, -2, etc. All right, and then let's say here's my graph. So here's my graph of f of x. X. Right, so the question is you want to find the x-intercepts, right? Find the x-intercepts. Okay, so as I said, x-intercepts are just the intersection of the graph with the x-axis. The x-axis, that's the horizontal axis. So where does my graph intersect my x-axis? Well, we do have like 3 intersections, right, of the graph with the x-axis. So we have intersection right here at -2, another intersection at +1, right, and another intersection at +3. Okay, so my graph intersect the x-axis at 3 different points at -2, +1, and +3. Right. So let me just write down here what I just said. So the graph intersects x-axis at 3 different points, right? So 3 different points. So these 3 different points, that will be my x-intercept. So to answer the question, so the answer, so x-intercepts are okay. So for the answer, guys, it's really important to use the points notation for the x-intercept. So what do I mean by points notation? I mean, so you need the x coordinate and the y coordinate. So for the first, so the first x-intercept, it's the -2 right here. Okay, so this is my first x-intercept. It's at -2. So x is equal to -2 here, right? But what's the corresponding y? So what's the corresponding y of this point? Well, this the level or the height of the y here, it's just, as you can see, it's just 0 because that's my x-axis. So the level or the height of my x-axis, it's just 0. So the corresponding y, it's just 0. Okay. So my first point or my first x-intercept would be -2. That's my x coordinate. So it's going to be -2. And -2, that's my input x or the x coordinate. Okay, comma 0. And the 0 here, that's my y coordinate. Okay, so just don't be confused, guys, between the, I mean, it's easier here to get confused between the interval notation and the point notation, and because both we use like the comma, right? But for the point notation, as you can see, we use always the parentheses. Okay, so the first number, that will be your x, input x, that's the x coordinate, and the second number would be your output y or the y coordinate. So my first point, it's just x equal to -2, y is 0. My second point would be right here, this one here. Oops, not that. So my second point would be, so here my x is +1, and again the corresponding output y, again because the level is just 0, but because that's my x-axis, so then the y would be also 0 here. Okay, so my second point, it's actually the point x is 1, the output y is 0 again. Okay. And my last point, my third x-intercept, would be this one right here. So x is 3, the output y, again, is going to be 0. So output y is just 0. So 0, right? So x is 3, and the output y is 0. So as you can observe here, guys, the output y in the x-intercept, it's always 0, right? Because the x-intercepts are supposed to be in intersection with the x-axis, and the height or the level of the x-axis is just y equal to 0. That's where y is equal to 0, right? Yeah. So that's like that's the answer here. So we have just the 3 x-intercept, and just keep in mind the x-intercept just intersection with the graph of the x-axis. All right. Any question, guys, about this example? Nope. Okay, so here's a small exercise just to make sure that you you understand this this notion of x-intercept. So here's an exercise. Okay, so just find. Oh yeah, before the exercise, let me just write down here. So as a remark, in the final answer, in the x-intercept, the y coordinate is always 0. So in the x-intercept, the y coordinate, the y or the output y is always 0. It's always 0. And that's actually, this is a really important remark. We're gonna use this remark later to find the x-intercept using equations, okay? So the y coordinate is always 0 in the x-intercept. So here's the example exercise, exercise. And then I'm gonna try to find the x-intercept using equations. Exercise. So please try to find the x-intercept. This is my x, of course. And then so this is the graph of f of x. Okay. So yes, please try to find the x-intercept. And again, guys, in your final answer, you should use the points notation for your final answer. I am going to give you 2 minutes to think about this. All right, I guess probably you're done with this exercise. Any guess? Matthew, you're saying negative 4, 0, negative 1, 0, 0, 0, and 3, 0. Perfect, Matthew. That's absolutely, yeah, that's excellent. That's the answer. So very good. So yes, so we do have intersection right here, negative 4, at negative 1, and also at 0, right? And then the final x-intercept will be at 3. So final answer, as Matthew said, so final answer would be, so x-intercepts are negative 4, 0. So again, please use a points notation for the answer of the x-intercept. And negative 4, 0, and then you have negative 1, 0, and then 0, 0, because this is just a 0 right here, 0, 0, and then finally 3, 0. All right. Any question, guys, about the? I mean, using graphs, I think it's not really hard. Now, using equations, we're gonna try to find the x-intercept using equations, and that's sometimes it's not easy, I think. So yeah. So next, using equations. So we're gonna try to find again the x-intercepts. Okay. Well, so the idea, guys, so we have a function f of x, right? F of x, and remember, guys, f of x, that's supposed to be our output y. So our y equals to f of x. And so we want to find the x-intercept, right? So the idea is that, so we want to find the x-intercept. So the idea is that, as I said, because the x-intercept are supposed to be the intersection with the x-axis, and at the x-axis, the y is supposed to be 0. So when you want to find the x-intercept of some function f of x, so what we have to do, the idea would be to solve f of x equals to 0. Okay, because when you say f of x is equal to 0, it means that your y, this 0, that's the corresponding output y, right? This is supposed to be your output y. So I'm trying to find the solutions of this equation, and the solutions, that will be the values of x for which the corresponding output y is equal to 0. And that's exactly where you have intersection with the x-axis, but when your y is equal to 0. Okay, so whenever you want to find the x-intercepts, all you have to do is to solve your function f equal to 0. So for example, let's say my f of x is equal to x squared minus 1, right? That's my function f, and I want to find the x-intercept. So then, as I said, what you have to do, guys, I mean, there's only one step here. It's I guess, a big major step. You have to solve f of x equal to 0. So what we have to do is, so we have to solve f of x equal to 0. All right, so like in this example, that will be x squared minus 1 equal to 0, right? I want to solve for x, of course. So let's solve this for x. So you're gonna get rid of the minus 1. So plus 1 both sides. So then your x squared would be positive 1. Now, this is not x, it's x squared. That's different. So you need to get rid of the square. And the way to get rid of the square is to apply the square root, of course. So that's square root both sides. So here's my square root. Here's my square root. And now, of course, you have to be careful, guys, because this is an even power. It's a square, so that's even. And because it's even, you're gonna need the plus or minus. So here, I'm gonna need the plus or minus. And just to remind you, if it was odd, if the power is odd, then you don't need the plus or minus. So then your x here would be, of course, well, square root of 1 is going to be equal to 1 because 1 times 1 is 1. So we're going to have two solutions here. So either x is positive 1 or x is negative 1. All right, so there are two solutions. X equal to positive 1 and x equal to negative 1. So then your final answer, your x-intercepts are, so first solution, it's positive 1. So it's going to be like positive 1, 0, because the y coordinate is going to be always 0 for x-intercept. And second solution, it's negative 1. So negative 1, 0. Okay. I mean, the next, in this chapter and the next chapter, we're gonna.
Professor, I have a
Yes,
question.
yeah, please.
How is x positive and negative 1?
Oh yeah, how I got this positive or negative 1 right here?
Yeah.
That's because, okay, you agree with me that x squared it's equal to positive 1? You don't have a trouble with this this step right here? X squared is equal to, okay. Then as I said, you need to get rid of the square. So to get rid of the square, you apply the square root, right? And the thing is, if when the power is even, like 2 is even, right? 2 is an even number. So when the power is even and you apply the square root or you apply the nth root, you're gonna need a plus or a minus here, right here. Okay,
You
so
said when the power is what, even?
even, yeah, even power.
Oh, okay, got it.
Because 2 is even, right? It's an even number. That's why. So for example, if I had a odd power, so let's say you have like x power 5 equal to positive 1, you know, you apply the 5th root because the power is 5. So apply the 5th root. So like it's 5th root of x to the power 5, and here 5th root of 1. But 5, it's odd, and when it's odd, you don't need the plus or minus. So then, like here, the answer would be just positive 1. So here, this 5th root cancel out with this power 5. So then, like here, x would be just positive 1. 5th root of 1, it's 1 because 1 times 1, like 5 times, would be equal to 1. So the answer here would be 1. But that's because the power here was odd, right? And yeah. So I'm gonna probably just erase this, what I just said. All right, any other question, guys? Anyone else? Okay, so here's an exercise for you. So you need to solve, you know, some equations. So exercise. So you need to find the x-intercept. Okay, so let's have like 3 different functions. So there'll be like 3 different equations. Let's see how it goes. So for number 1, your f of x is just like 3x minus 1 over x plus 2. Number 2, your f of x is square root of x minus 1. Minus 2 outside the square root. And finally, let's have some quadratic function. So let's say it's 4x squared minus 3x minus 1. And let's do another one. Let's have another number 4. This is f of x equal to x minus 3, let's say, times x plus 4. Okay, guys, so please try to find the x-intercepts. Oh yeah, by the way, guys, the number of x-intercepts depends on the problem. So here, like in the previous example, we got like 2 x-intercepts, right? The 1, -1. In the example before that, we had like how many? Well, we had like 3 x-intercepts, right? So the right here, sorry, we had like 3 x-intercepts, right? So the number of x-intercepts, or the intersection of the graph of the x-axis, depends of course on the function f, or the graph of the function f. Okay, so we can get like 10 x-intercept, or like just a 1 x-intercept. Depends on the graph of the function. So let me just write it as a remark right here. So the number of x-intercepts depends on the function f. Depends on f of x. I mean, it can go like from 0 to, I don't know, infinite number of x-intercepts, I guess. Oh, we have only 4 minutes. Okay. Yeah, so just to remind you guys, so Wednesday we're supposed to meet in person. So I guess the plan on Wednesday would be to, first try to, yeah, after the x-intercept, of course, we're gonna try to find the y-intercept. That will be intersection of the y-axis. And then I'm gonna talk about, the range. I'm gonna come back to the range and see how to find the range using equations. And then I think we're almost, then we are done with this section. And then, and then we can move to the next one. So you have like 4 different kind of functions here. All right. So like number 1, it's like a quotient, a fraction. Number 2, you have like a square root. Number 3, you have like a, quadratic equation. Well, you know what, guys? I'm gonna probably discuss the first function because we have like just 2 minutes. So I'm gonna discuss the first function, and then so you're saying for number 1, you're saying -2 the answer. I'm
Geometry. Number 1 is 1/2.
Nope. Actually, number 1, the answer is supposed to be 1/3. Okay, so in the last 2 minutes, guys, number 2, your answer for number 2, it's correct. So for number 2, the answer is it's 5. But don't forget, for your final answer, x-intercept, so it should be like 5,0, right? So let me just in the last 2 minutes, guys, discuss the first problem, the first function, and then I will continue with the other ones on Wednesday. All right. So let me just discuss the first problem. So for number 1, so your f of x, it's 3x minus 1 over x plus 2. And as I said, so we're gonna find the x-intercepts. You want to find the x-intercepts. So so we have to solve f of x equal to 0. So then that will be 3x minus 1 over x plus 2 equal to 0. All right, guys, whenever you have a fraction, so this is a fraction, right? This is just a quotient or a fraction. So whenever you have a fraction equal to 0, it means that the top is 0. So Matthew, you're saying 1.5 for number 1. Actually, no. As I said, it's going to be 1/3. So the thing is, so if you have like a fraction like a over b, okay, equal to 0, then it means that the top is 0, a is 0. Okay, because if you have 0 over any non-zero number, that would be 0. Okay, so whenever you have a fraction equal to 0, it means that the numerator is 0. So then the top is 0. And the top here, that's the 3x minus 1. Okay, so yeah, let's solve like in 30 seconds the 3x minus 1 equal to 0. So that you're gonna need a +1 both sides. So that will be 3x equal to +1, right? And then of course you have to divide by, get rid of the 3. You have to divide by 3 both sides. 3 over 3, that will be 1, so it cancels out. So your solution x, so your x would be 1/3. So the answer to the number 1 would be 1/3 0. So my x-intercept for number 1, it's 1/3 0. So all you have to keep in mind, guys, if you have a fraction or quotient
Yo,
equal to
what's good?
0, it means that the top is 0. All right. Oh, you made at the bottom equal. Okay. Oh, yeah. Okay. Yeah. I see the, yeah.
And
All right,
Professor,
guys,
how
I'm
did
gonna-
you get the 0?
Excuse me? How I got this 0? This 0?
No, the 0 next to the 1/3.
Oh, that's always the case because remember for notation for the x-intercept, we said this would be like the input x, but the 0 here, that will be like your y. And the y, we said it's always 0 for the x-intercept, right? Because that's like when you intersect the x-axis, your y coordinate or the level y would be always 0. That's always 0 for x-intercept. Okay.
Oh, so y is always 0.
Yeah, y always 0. Yeah, absolutely. All right, guys, I'm gonna stop here. I will see you on Wednesday in person. So and I will finish this problem next time. Okay. Thank you for listening, and I will see you on Wednesday. Take care.
Thank you,
everyone.
goodbye.
Goodbye. See you next time.
Professor, you
Yes.
still there?
Yes. Yes.
Did you grade the homework?
Oh, I'm not done yet. I'm not finished, but on Wednesday I will for sure.
Okay. And we're good on assignments right now, right?
Yes. Yeah. We're gonna have
Fabulous.
yeah.
Okay, thank you, bye.
Thank you. Thank you, everyone. Bye.